The scientific method is familiar to us all. We are curious by nature. We ask questions about the world around us, and we seek to understand our lives as well as the environment we live in. But what exactly does the scientific method cover? Most professionals view their work as an art, most business owners view their operations as a science, and all scientists are people. So what exactly is the connection between science and art? Hello everyone. In the first lecture we discussed my background and asserted that rhythm is an unidentified fundamental physical principle. I also demonstrated that language is the basis of mathematics. In this lecture, we will be proving that a formal understanding of music is completely unknown, a formal understanding of emotion is completely unknown, and that vibration connects music and emotion through language. To accomplish this, we will be reviewing some known facts and conducting a couple simple experiments of our own. What this will do is convince anyone in one short lecture that there are large gaps in physical theory on a profoundly basic level. A so-called subject or research discipline develops when there are measurements that introduce new data. When the data does not fit the presiding explanatory model, data trumps the model 10 times out of 10. Current theoretical physics consists of two seemingly fundamental but incongruent mathematical frameworks. Quantum mechanics was developed in the early 1900s after several very confusing experiments and has been improving to what is now known as quantum field theory. During that same time, Albert Einstein independently developed insights for what is known as general relativity. The insights for general relativity are founded on intuition and common sense, whereas the basics of quantum mechanics has never been confidently understood. These two research subjects compose the two major pillars of modern physics. When you have one explanation founded in sound logic, and the other explanation as a piecemeal construction of post-experiment ideas, the sound logic will always win. To prove this, we're going to start with a fun oddity that I bet most people have seen before. Take a pen or pencil and jiggle it to try to make it look wavy. When the pen is stationary in your hand, you see a straight edge. When you jiggle the pen in time, you form a rhythm, and your eyes perceive a curve. This simple demonstration has serious implications for quantum mechanics. When you take quantum mechanics in college or at a research caliber, people will discuss what is called the wave-particle duality. Wave-particle duality asserts that all matter behaves both as a particle and as a wave. But what exactly is the difference between a wave and a particle? And how does that relate to a little pen trick? What the motion of the pen proves is that quantum mechanics is not a unique domain of mathematical insight. Allegedly, physical systems behave bizarrely and uniquely at lengths less than about 10 to the negative 36 meter. When you jiggle the pen, you see a quote-unquote macroscopic object demonstrating wave-particle duality at speeds hilariously less than the speed of light. Now, any physicist worth half his wits will bring up what is known as the de Broglie wavelength, which says all objects with momentum have some sort of wave-like behavior. What the motion of the pen demonstrates is that rhythm is the physical phenomenon that accounts for wave-particle duality in all physical systems, regardless of the energy or length scale. Physicists of our day are well aware of the wave-like nature of objects in motion. But the pen proves you can elicit this duality without accelerating particles to the speed of light or measuring below the Planck scale. Quantum mechanics is not bizarre, people are. What I have developed is the proper mathematics needed to correctly demonstrate that the insights of Albert Einstein and subsequently of the framework of general relativity account for all the phenomena described by quantum field theory, and all the phenomena observed in nature. Our boy Bert never finished his work, and it was very clear where he was stuck. He never understood the role of the cosmological constant, which is the mathematics term for dark energy. Dark energy is a placeholder term for the assumptions needed to account for an expanding universe, and dark matter is the placeholder term for the assumptions needed to account for the rotational velocities of galaxies. The data says the universe is expanding at an accelerating rate and that galaxies spin too fast. That's it. When physicists come on TV and say, "We know dark matter exists," that is a straightforward lie to keep up the status quo. Physicists are as confident dark matter exists as a child is confident that Santa Claus exists. They have good reason to believe that heroic story for some amount of time, then reality sets in. Frankly, You can't say we know something exists that you have not measured and you never will. Furthermore, quantum field theory is known to be incomplete while simultaneously being logically exhausted. What I mean and what is well known amongst informed cosmologists is that it is impossible to theorize any new particles with what has already been incontrovertibly proven in quantum field theory. It's cute to believe in Santa as a child, but an indication of psychological problems to believe in him as an adult. Same with the so-called dark universe. Now, with no further explanation of quantum mechanics, quantum field theory, dark energy, dark matter, or general relativity, I am going to try to convince you that with a proper understanding of music, there is no need for all this dark nonsense. Any reasonable human being couldn't possibly deny the prevalence of music in our lives and in our culture. Whether we are happy, sad, working out, or simply going about our day-to-day business, music bolsters our emotional states and makes us feel connected. Take a moment to consider how you felt at your favorite concert. Everyone knows what it's like to be at a venue and the atmosphere is absolutely electric. The people you are with are all in a good mood. The weather is nice. The band is crushing the tunes. Any given person might then be inclined to remark, "Wow, bro, these are some good vibes." In the same way you cannot watch a sports game without hearing the word rhythm, you cannot watch any show or describe a conversation without someone mentioning a vibe. So what exactly do people mean by a good or a bad vibe? With music being so universally appreciated, people know how to describe music properly, correct? Simply, no. Pause this video and take 5 minutes or so and Google what is music and what is music theory, and there simply is no distinct and satisfactory answer. So how in the world do we reconcile the fact that everyone knows intuitively that music is fundamental, and yet no formal description has been articulated? Simple. People haven't figured it out yet. It is extremely easy to demonstrate this with an acoustic guitar or a piano. As you can see, when I play the low E string, the high E string also vibrates without being directly contacted. The guitar strings are tuned by tightening the knobs to create tension in the string. The oscillating string vibrates the air molecules, which then cause the other E string to vibrate in unison. A guitar string, or a piano string, is tuned to a pitch called a note. A series of notes played in a given interval creates a key. A key is a set of notes that are resonant together. Resonance is vibration. Musicians can play together because musical notes and keys are independent of the instrument being played. Musical keys literally create vibes. There is not a single person who would not say a minor key sounds sad in comparison to a major key that sounds happy, clearly demonstrating a fundamental connection between music and emotion. Now think about your childhood and about learning your native language. You probably don't remember any specifics. Known science shows us no one remembers their first words, let alone their first years, due to the constant rewiring of neural circuitry when exposed to stimuli in our infancies. In adulthood, we don't remember the vast majority of most days for the simple fact most days are just not that interesting. Furthermore, most poignant memories are encoded with emotion. We remember the best and worst days of our lives like they were yesterday, but can't remember mundane events with any sort of consistency. But everyone learned their first words from their environment. People learn language instinctually as a tool of communication from their parents, guardians, and communities. Now think about the bulk of humanity together, and not just yourself. Any given individual lives such a small amount of time in comparison to our species collectively, that it is most appropriate to view language as a tool for our species as a whole. People grow up, have children, and pass useful information on to their posterity with words, stories, and analysis. It is an evolutionary fact that humanity is one species that developed out of Africa. So then why in the world would our language be different in any fundamental way? It wouldn't, and it isn't. The set of sounds that human beings can and do make to form words from every language is completely known right now today. Over thousands of years, human beings spread out as hunter-gatherers, then developed agriculture, then developed cities. With the spread of technology, the world has become profoundly more connected, and yet there still remains pockets of isolated human beings as hunter-gatherer tribes who also use language. So what can we learn from these groups, and what can their linguistic structure teach us about our environment, our history, and our mathematics? The pariah tribe of the Amazon jungle is a quintessential example. This tribe of about 800 people speak a language with a one-to-many counting system. They have no word for time and no words for numbers past 2. Now remember in my last lecture when I said people have only ever conducted measurements in 3 dimensions, and this tribe is culturally isolated from the rest of society. What this demonstrates is that no one has ever interacted with an object in less than 3 dimensions or with an object that has less than 3-dimensional components. You don't create words for things that don't exist, and people in the jungle have no formal education. They simply build linguistic structure from the sounds in their environment. Because the set of all sounds that can possibly be made is completely known, it would not be possible to create a vocabulary to discuss a new fundamental insight. Therefore, the diction to describe the unknowns of physics must already exist, and we simply haven't put the logical pieces together. You need words to describe things, and this simple fact limits the types of physics discoveries left to be made. Now, a question for you to try to answer in earnest. Where is your voice located? Your voice is not located anywhere. Speaking is a vibratory process, not a state. Just like the tension in the guitar string, right now I am contracting my lungs to vibrate the air to form words that then travel to you through the microphone, saved as data, which is then recreated on your phone or computer. The point of this is to show you there are seemingly logical questions that do not have well-defined logical responses. Asking, does the onion stop red? Sounds like a question, but there's no discernible meaning. Asking where your voice is located is still nonsense, but makes you pause and think about what a well-defined question really is. Additionally, every American English speaker is aware of the fact that Australian, British, and other English speakers do not seem to have an accent when they sing. This demonstrates that vowel sounds are independent of any one given language. Vowels are the sounds that produce resonance, and the inability to transition from one vowel or consonant sound to another produces an accent. Sound came before language. Now I want you to think about the learning process in general. In my last lecture, I established that all people use language to solve problems, but not all people are necessarily mathematicians. My point being that all people learn the same, and all disciplined people act the same. All skills are learned through the slow and tedious process of trial and error. No one was good at anything before years of consistency and hard work, and there is simply no special sauce to the learning process. Any skill that 2 people can learn, anyone can learn if they take the time to do so. The connection between art and science is the learning process itself. People who do take the time to learn build discipline and grow their creative capacity. The ability and capacity to think takes time and energy to train, just like any workout plan to build a good physique. I titled this lecture, Nothing Says Bad Vibes Like Dark Energy, because if you ask any reasonable person their thoughts on the likelihood of dark matter or dark energy being real, they actually laugh. While it sounds like a joke, it just isn't. Dark matter, dark energy, and now dark fluid is literally a painful statement of incompetence. As you may have seen in the news, CERN out of Geneva, Switzerland is proposing another super-duper stupid collider for a not-so-small price of 21 billion euros. Let me explain in no uncertain terms why that is a hideous waste of money. The super collider they have now discovered the Higgs boson, which has produced a grand total of $0 worth of useful technology for society. The proposed future circular collider, so-called upgrades, will produce collisions a measly 6 times greater than the LHC, which in physics scales is irrelevant. Let's consider building this next super collider with the ever-elusive common sense of ours. Imagine every year you house sit for your grandparents over Christmas break, while simultaneously babysitting your little cousins. Every year, you and your whole family open presents Christmas Eve, then your grandparents leave for a week through New Year's. One Christmas, your little cousin asks your grandma for a hammer for a science experiment. Grandma, being the fan of science and education that she is, gets in the hammer. The next day, your little cousin Johnny then says to you, "Hey, I'm going to smash Grammy's fine china with this hammer as my science experiment. I read on 4chan that if I smash it hard enough, a gold bar will pop out." You, being the ever-astute scholar, advise little Johnny against his experiment. As little kids do, Johnny completely ignores you, grabs the hammer, and starts going to town on the dinnerware. To much surprise, no gold bars pop out, and Johnny is very sad. When Grammy comes home and finds her favorite china destroyed, the last thing little Johnny is going to get next Christmas is a bigger hammer for another science experiment. All jokes aside, the logic of little Johnny is the same as physicists expecting to smash highly energetic particles together to teach us about the so-called dark energy and dark matter that for sure does not exist. The fact that such simple and highly intuitive phenomenon such as music, emotion, and the flow of liquid have not been described properly or at all, focusing research efforts on a multi-billion-dollar, multi-decade project is absolutely ludicrous. Every salesperson claims to be selling the best and the greatest gizmo. CERN's claim that smashing shit together real super duper fast is a priority or even remotely useful is a narrative of delusion by well-intended but sadly highly incompetent experimental physicists. Use your common sense, not your hammer.